the question given to us is that we have to find the number of irrational terms in the expansion of this. Before we go ahead, let us recap the theory part, related to binomial expansion. For any expansion, say a plus b whole to the power n, we have n plus 1 number of terms. The other thing is that the r plus 1th term is given by the formula ncr a to the power n minus r into b to the power r. Now here we have to find the number of irrational terms. Rather than finding the irrational terms, let me find the number of rational terms. So if I find the number of rational terms, I can deduct from the total number of terms and will get the required number of irrational terms. Now this particular term can be written as, or I can write under root of 5 or 8th root of 5 plus 6th root of 2 to the power 100 can be written as, for simplification I am writing it in this way, that 8 to the power 1 by 10 plus 2 to the power 1 by 6 whole to the power 100. Now let me find the r plus 1th term of this particular term. The r plus 1th term will be 100 cr into 5 to the power 100 minus r divided by 8 into 2 to the power r divided by 6. Now we can see that this term will always be a rational number. For this term to be rational, the value of r must be multiple of 6. So we can say that r should be having values such as 0, 6, 12, so and so forth till 96, because the maximum value r can take is 100. So the number which is less than 100 and a multiple of 6 is 96 here. Similarly, for this term to be rational, the numerator, that is 100 minus r, must be divisible by 8. So we can say that 100 minus r must be of the form 0, 8, 16, 24, so and so forth till, say, the last few terms I am writing here is say 80, 88, 96, etc. In fact, the 96 will be the last term. For this particular thing, let me find the value of r. So if 100 minus r is 0, then the value of r would be 100. If 100 minus r is 8, then the value of r would be 92. And if it is 16, then the value of r would be 84. So and so forth till the last, it will be 20. This will be 12 and this will be 4. Writing this number into the increasing order, I can write the value of r, the value which r can take, such that the first term, that is this term, will be an integral, will be a rational, will be given by, for value of r which is equal to 4, 12, 20, so and so forth. The last few terms will be 84, 92 and 100. Now if I take r is equal to 0, this term will be rational, but this will not be a rational term, because r is not taking the value 0. This r is for 6 and this r is for 8. So I am just differentiating these two r. Similarly, if I take r, the value of r to be 4, then the first term will be a rational term, but second term will not be a rational term. So what do I need to do? I need to find such a value of r which gives me a rational, which makes both the terms rational. For example, you can see that the value of r, if I take to be equal to 12, then it satisfies both the terms, that is both the terms will be rational. This is the minimum value of r such that both the terms are rational. The other terms will have can easily be found by taking the common terms from this series and this series. Now how do we find the common terms? If the two arithmetic progression or two arithmetic series are given, arithmetic progression series are given. So what we do is we find the first term and then we find the common difference. The common difference d is given by the LCM of the common difference of the two series. So here the common difference is 6 and here the common difference is 8. So LCM of 6 and 8 is 24. So we have identified the first term, that the first common term will be 12 and the common difference will be 24, and the term will go till the value 96. Will not be taking 100 because we have to take the smallest among the two series given. So it's very easy to just identify we don't have to apply the formula. So the first term will be 12, the next term will be 12 plus 24, which is 36. The further the next term will be adding 24 because I'm just adding common difference, so I'm generating that series which will have terms common to both these two series. So the next term here will be 60, another term will be 60 plus 24, which is 84. And now if I add 84 plus 24, it gives me 90. It's basically above 100, so anyway it will be discarded. So the value of r for which the given expression will have rational terms will be 12, 36 and 60 and 84, that is 4 values. Now what do we need to find? We need to find the number of irrational terms. And how many terms it will have? The value of n is 100, so the number of terms, let me write it here, the total number of terms will be 100 plus 1, which is 101, out of which there will be 4 terms which will be rational and rest other terms will be irrational. So the answer for this question will be total number of terms is 100 minus number of rational terms is 4, so 97 terms will be irrational. This is the answer.